Well, good afternoon, everybody. If you're just joining us, you're very welcome to Hall1B. My name is Gemma Simpson, and I'm the host for this afternoon. There are no planned fire drills, so in the event of an alarm, please escape quickly and calmly through the two back exit doors. So this afternoon, I am delighted to introduce Karl Kyck. Karl is actually part of Liberty IT, who are a diamond sponsor of ours at NIDC. In today's fast-paced software delivery landscape, delivering high-quality software at speed has become a critical business need. So Karl is going to be talking us through a journey to deliver quality software. Thank you.
Lovely. Thank you very much. Oh, good. The mic is on. Hey, everybody. Great to see you here. It's lovely to be here in Belfast. I do love Belfast City, so it's fantastic to be here to share this with you today. Nice one. I hope you are all well fed, right? Feeling good after the lunch? Good stuff. And you've been seeing some good talks, listening to some good talks that are out there. Okay, so I'm Karl Kyck. I'm from Liberty IT, obviously, and I'm here to talk about testing excellence. So it's a journey that Liberty IT are undergoing right now to reinvigorate our testing practices and raise the standards for all in our organization and improve that quality of our software for business value reasons. So this is me here. I've been in Liberty IT now about 3 years. And of course, I've been to many places before that. So I started my career in 2000, so I'm a Y2K graduate, right? And I've seen a lot of places, seen a lot of things, and in every single one of these places, I've seen a real need for quality software engineering and testing practices over time, right? And so much so that it is part of my muscle memory, so I built it into the process. So I've seen it save ass too many times for it to be chance, right? And I've just made that as part of muscle memory, and it's something that I do. That doesn't mean, though, that you just blindly trust the process, right? You have to keep on going back and refine that process over the years, and that's what I've been doing for all these years. Once I finally discovered, testing and the benefits of having really good quality software and good pipelines to produce it, right? So, of course, I wasn't always this way, right? I wasn't always into testing. I arrived out onto the scene, right? I was the ultimate programmer. I was God's gift to programming, right? Every line of code that I put out there is the ultimate line of code, touched by the hand of God, right? So that's how good I was. And of course, arrogant, unpleasant individual, right? Bit of an asshole, right? Not much has changed really since then, but I do my automation testing, so that's fair enough, right? So I remember the days, you'd be there and you'd be hacking out on the computer, hacking out all your code, right, over weeks, right, months, getting all the features going, everything like that. And how I did my software and testing at the time was I'd boot up an Oracle database on my local machine. I'd be spinning up my application server, and I'd be whipping open my web browser, and I'd be clicking on things and seeing if I could break them and all this kind of stuff. Then I'd be going back in, hacking some more. And because, the hot reloading, either it wasn't in existence back then or it wasn't very good, right? I'd have to restart the server, and I'd have to do massive feedback loops to getting this software out the door. And of course, when I did finally amass enough of these features, right, over weeks and months, what did I do? I threw them over the wall to the testing team over here, right? In a totally different area, perhaps even a different floor or whatever it was, right? So they'd get hold of it. And while they're there testing it, and it's taking some manual tests in a couple of weeks or whatever it is, I'm off hacking on more code and producing more bugs and all sorts of crap as part of my code, right? And they come back to me with a list of stuff that's broken. And I go, how dare you question me, right? I am the ultimate software developer. Did you try restarting your machine? You're not using it right. This kind of crack. Again, arrogant, unpleasant, right? Belligerent developer. So I'd take this list, and of course I'd scurry back to my, I'd go, I'll look into it, and I'd go back to my machine and go, okay, I've got to check this. So I'd start all the databases, start all the servers and everything like that, clicking, and sure enough, broken. Didn't meet requirements, broken completely, whatever it was, broken, right? So then I'd be existential, oh my God, question myself, right? Imposter syndrome, the whole lot, right? Am I a good developer? I tell you what, I'm going to fix this with more code, right? More code, getting hacking away on the code, churning out more features, right? Introducing more bugs and problems. And then what do? Fire it over the wall again. And you got this massive feedback loop. And it's taken months, and it's taken loads of time and money, etc., right? So I didn't get the wake-up call until 10 years later, in 2010, right? So I had seen glimpses of it, but I just wasn't paying attention. Again, arrogant, right? So I dropped into Citibank. And you know when you meet, I met this person there, really excellent software engineer. And he was doing stuff way, way ahead of his time, or whatever it was. He was just doing stuff I wasn't aware of. Great stuff. Sean Duddy is his name. He's a Staff Plus engineer still there. And he was doing things like code reviews. Wow, amazing stuff, right? And we didn't have Git or anything like that back then, no PRs or any of that kind of stuff. He was throwing code reviews out using email. So you're getting these emails, the email go out to the whole team, and he'd be going through your code and he'd be critiquing. He'd go, what are you doing critiquing my code, right? Still not getting it. It's not my code, it's our code. It's the company's code, and we're learning together and we're lifting all boats, reviewing this stuff, right? And then he was doing other interesting things like unit testing with mocks, and then he was doing interesting things with test doubles, right? So he was firing up an in-memory database to test, mocking out Oracle, to test the ORM, the object relational mapping between our objects and the repositories that we had using Spring and the database. And it was really fast. He was just doing a little kind of unit test, still talking to something external, right? So it had that integration test feel to it. But it was really super stuff. But I still didn't get it. And it wasn't until I got a tech lead position over a team, right? And then that's when it came home. Now I was on the hook for a lot of stuff, right? I was the one who was on the hook for the quality of stuff going out there. And again, arrogance, just me. It was the team working on this stuff. But really, I was the one person, that visible person, right? That conduit, that connection with the management. I was on the hook for that stuff. So quality became really important really, really quickly. The app that we were working on was like a login system for Citibank's banking portal. So they had web, they had the mobile stuff, and they had tablets as well. And so they had a lot of transactions. This thing had to work, right? But they also had really high volume money transactions going through. So around about then, the iPad had just come out. So all the execs are there on their iPads. Oh, I should get my iPad. It's all like, gilded in gold or something like this, right? And they're out here, they're making billion-dollar transactions on this thing. So the thing had to work. And there was a lot of pressure on us to get the thing to work. So it really came home when I was working on the software one day. Everything was cool, switch off the machine, come in the next day, everything was broken. Didn't know what the hell was going on, right? Knew straight away that we had to up quality and get the feedback and the automations and all that kind of stuff in place. And that's when, you're familiar with the testing pyramid, unit testing, integration, end-to-end testing. We threw the testing block at this thing. So we had all the unit tests, all the integration tests, all the component tests, all the end-to-end tests, completely, repetitive, all the different test cases repeated across it, lots of duplication, right? And we even put in a test harness for our tester, who was absolutely brilliant. Our tester knew more about our application than we did, right? And it gave him a DSL to run his test cases. So all these test cases duplicate. If they made one change, you'd have to change all these tests up. So it was inefficient, highly inefficient, but it did give us the coverage and the confidence we needed, right? So I always knew that there was something up with it, even back then. But that's where the testing came in and how I knew it was saving my ass. If we'd have moved forward, more clients, more types of authentication system for the login system and things like that, it would have ground to a halt over time. But we did have the coverage, and that's where the learning journey began with the testing. So this is more like what we want to get to. If you see the Wile E. Coyote here, right, that's your quality issues trying to catch you and eat you for lunch, right? And then we've got the Roadrunner, right? And the Roadrunner's ripping ahead. And look how serene the Roadrunner is. He's just like ripping ahead, and he just casually looks back and raspberry to the Wile E. Coyote as he's flying ahead, right? That's where we want to be. We want to be confident, but we want to be able to do that at speed and with efficiency as part of our testing, because testing is so important to giving us that confidence to go out into production with speed. Right, so how does this relate to LIT? So in LIT, we're starting to get certain indicators that there might be, issues within, with software quality in the organization. There's pockets out there of excellence that we have that are really good teams doing really great things, but, the standard, raising the standard across everybody is really important to us, right? So there's a part of our organization, and what they have for several months is a release freeze. No code goes out during this time because they want to protect the revenue stream coming in. It's critical business time, right? Function, right? No releases. So in the meantime, while there's no releases, to stop code going out there, because guess what? The code breaks, and it's a risk to the business. They don't want to risk it, right? All the developers are off in writing all these features, and the more features, the more risk the more risk, and then when you finally do put the thing out there, what's going to happen? It's going to break. And it's going to be harder to find where it broke, and it's going to take longer to fix it, etc. So this is like a self-fulfilling prophecy, right? They've got a coverage issue. They've got a confidence issue, right? Another part of the organization, it's all about scale. This here is like the Ever Given or something like that, stuck in the Suez Canal, the poor little digger trying to dig it out, right? You got a part of the organization, say doing auto insurance in the US, massive, right? All these different services and systems, different teams looking after all these things. To do their testing, they do a lot of end-to-end testing. All these services and things all have to be up, running, perfect, communicating with each other, and the test data across all of it all has to line up before they have an automation test suite run across this, which takes ages and isn't all automated either. So we have scale issues as well. And then there's our wonderful developers, right? They have come forth and they are saying to us, we do not want to have to reinvent the wheel every time we go after testing. We want standards, guidance, tools, techniques, practices. We want to streamline this stuff and get it to the point where, testing over here is very similar to the testing over here, which is very similar to testing over here, and you have that kind of mobility between teams and also that pollination as you go, right? So as I say, this is coming up in the LIT, it's coming up in Liberty Mutual as an organization now. This is not the first time we've seen. This is not the first time that we have been focusing on testing. Right? It has happened before, and good old Wolf here talks about the theory of the Mobius, right? That infinite loop, that time loop that you go through. How do you break out of the loop, right? What is it about now, and why are we seeing testing come up again? We tackled this before, we did a good job. We rose unit testing across the board, we rose other testing practices, but how do you make it sticky this time? How do you make it so that it evolves and it continues and maintains momentum beyond individuals, right, who move on, people coming and going, people getting promoted, things like that. So how do you build a community around this? And how do you build, a practice around this? So this is exactly what we're doing. We're building a practice and a community around this. We're concentrating all firepower on we're having a conversation together. What does good quality automation testing mean to us, right? And what we want to do is we want to standardize that. We want to standardize the tooling, the practices, get rid of all those, conflicting, information that you see out on the internet, right? Just look at Martin Fowler's blog on integration testing. It has had totally different meanings, well, not totally different meanings, but different scopes and things like that over the years, right? And settle on what it is that we need, settle on the coverage that we need across the different layers of testing. So we have that confidence, all right? And what we're doing is we're taking all these best practices, right? We're taking all the best stuff that we see out there. We're cutting through all of the different conflicting information, all these tools, techniques, and we're putting it in a practice library. So this is what we call the high-performance engineering practice library, right? And in there's a testing section. And in the testing section, we're committing to it. We're saying, this is how we do the testing, these are the different levels, this is what we do, right? These are different practices that you can leverage, where, when, and how, okay? And the reason why we want to do that is because we're going out and we're going to talk to the teams. Now, every team's going to implement exactly the same thing. They'll have their context. They'll have different blend of the different practices and different tools and techniques, right? So as we're chatting to them and building up that context, what are we referring back to? We're referring back to the practice library. Instead of all these different, wiki pages all over the place for different teams and all that fragmented knowledge, right? We're putting it in one place where we can focus our efforts and we can have our opinionated practices and direction with sensible defaults. So this is cool. On our, when we went out there to look at all the cool stuff that was out there and bring it back into the company, one of the things we found was the Agile Testing Manifesto. And this is fantastic, right? So if you look at this, right, they're talking about testing throughout, not at the end when it's at its most, expensive, right? You want to test throughout. Every step of the way, you're testing your understanding as you go along. You're putting it in. You're trying to put your testing and catch stuff early in cheap test phases, as cheap as possible, right? And that helps you prevent the bugs from getting out in the first place. So instead of finding them over here, what you're doing is you're thinking about, what am I building over here? And you're putting in the tests to validate that knowledge, right? The next piece is, testing your understanding. You're testing your understanding through putting these test cases in place to test your understanding of how the code and how the behavior of the application is supposed to work all throughout the life cycle. Cool? And because you're doing that, you're building the best system from the outset. You're not trying to break it on the other end, with a totally different test team. You, developers, working with tests to understand the product and build in those tests to validate your understanding, right? And then the last one's really interesting. It comes back to that arrogance thing again, and my code. No, I didn't write that code. That's not me, right? It's a team responsibility for quality across the entire team. We work together to improve as a group, to improve our code base, to improve how we do our testing going forward. And not just at the team level. You want to elevate that up even further. You're part of an ecosystem, a whole program full of teams working on different services and things like that. It's not their service. They're always broken. Do something about it, right? Doesn't mean you have to do it for them, but you can give them the value of your experience, and you can raise all boats, and you can come together as a whole group of teams and agree on what testing means to you. Okay? So, that was the test manifesto. So that's like principles, right? Principles to drive you, guiding principles to bring you forward. Now, we have to talk about coverage. How are you going to get that nice spread of the different, coverage so that you have the confidence going out? And this thing here is called a test quadrant, right? And you can see across the test quadrant, you got the different types of tests. Some will be faster than others. But across all of these, this is what you're getting to get that basic coverage, right? And you've got your behavior, top left, right? Business behavior. You've got your code design, code implementation, etc. Bottom left. Top right is your manual stuff, exploratory testing, user end testing, things like that. Exploratory, very important. I'll talk about that in a minute. And then bottom right is like, security testing, SLAs around performance, capacity testing, things like that. These give you that nice spread of the different tests in order to get the confidence that you want going out the door. Okay, so this is what we arrived at. Now, I know the testing pyramid gets a bit of hassle these days, and different shapes and stuff like that. But I do feel it still gives it gives you a good indication of what is, see, slow, brittle, and costly up the top there, end-to-end testing. And then how do you drive tests and your confidence, right? How do you drive those test cases that give you the confidence into lower, which are faster, more reliable, and cheap test phases, which are lower down on the pyramid, right? So if you think about it, right, your unit test, right, what's that doing for you? So that's your code design. How modular is your code? How testable is your code? How good is that code looking? And there's health checks and things like that you get through Sonar, etc., static code analysis, right? How good is that code looking? You could do that at the unit level. They're fast. They're cheap to do. You can catch a lot of stuff really early before it even gets into different layers, right? Then you go up a level, look at the integration testing. What you're looking at there is you're designing how your application is going to talk to an external dependency, right? You're going to have to think about, protocols. Is it REST? What's the contract? How am I going to deal with errors? How am I going to deal with retries? Replays, idempotency, things like that. You're designing this stuff. You're thinking about how it's going to have to interact. You're putting that down as tests, right? To validate your understanding of how it's going to work. Then you write the code to make the test pass, right? That's what the integration testing is about. You go up another level. Right, and if we drop to it with the integration testing, they go a bit slower, but if you design them through narrow integration tests, they could go really, really fast, right? Up another level, and this is where we get opinionated again, component test. That's where, it's a minimal deployable unit. You start the app. All your external dependencies, they're testables. You mock them out using testables, okay? That way you can control the environment when you boot up the tests, the application. You fire in your request, and now you can exercise the behavior that you're looking for using the testables, all right? And then you can exercise that behavior and validate your understanding of how that component is working. All the units are connected to each other within the black box, within the application that you're looking at. And then end-to-end testing, as few of these as possible, because you've already gotten maximum confidence from the lower layers, right? You've gotten all this confidence around your code, how it interacts with external dependencies, how it's going to behave. What's left? Can the thing talk to other things? That's networking, it's firewall rules, things like that. It's things like IAM, privileges in the cloud, right? And then the exploratory, this is critical. If you're up and you're going to do some exploratory testing once a week, whatever it is with the team, if you're finding things, right, how did you miss them? Use those to identify gaps in your testing processes to push testing into lower phases. So, this comes from the DORA, so the DevOps Research and Assessment, right? And they have a whole measurements. They have an automation testing page. And they have a measurements piece on there, right? And one of the measurements that they use is more bugs are found in cheaper test phases. How are you challenging yourself to take end-to-end tests or even components or whatever, and push it down into those lower, cheaper, more reliable and faster test phases, so you can have those quick feedback loops and get the feedback quickly, work on it cheaper, and then don't let those bugs escape. This is how you prevent them, right? So I absolutely love this measurement here, right? And it's a guiding principle. So this is an example of like a testing strategy. It's kind of hard to see here, but basically what we're saying here up on the left is that you can get on a local machine, right? If you set this up well, you can get your static code analysis, your unit tests, your integration tests, and your component tests, which is like your acceptance tests and BDD and stuff like that, locally and as part of your build, right? And super fast feedback loops. Now, some of them have penalty in how long it'll take, to run them. You can even run them individually as you're developing or whatever it is, but that's how early you can get the feedback. It's fantastic. Before you've even deployed the thing. Cool. Like I challenge you, can you do the tests and do these things before you deploy? Get the feedback really, really quickly, and they'll be able to move on to more expensive phases only when you need to test those few edge cases or things that you need to do to wrap up. Right. So to talk about speed, I'm going to have to talk about the different types of test doubles. Okay, so there's the dummy, the fake, the stubs, the spies, and the mocks. They have their place in these different areas, right? And if I read here, dummy is object that passed around but never actually used, right? I don't really use those ones. Fake now, fakes are objects that actually have a working implementation but usually take some shortcut which makes them not suitable for production. That's the in-memory database, for example. Or test containers, right? If you're doing a narrow integration test, which is just testing the code that talks to the external dependency, you don't have to boot everything up, just the code that talks to the external dependency. The external dependency can be booted up. It could be a Postgres database in a test container. You apply the schema to it, give it the seed data you need, and you've now created a controllable environment for you to run your test and exercise the behavior for the interaction. How to handle failures, how to handle the mappings, etc., and do all your permutations right there as close to it as possible. So, and more expensive phases, you don't have to do as many permutations. You just have to know the thing talks to the database, right? And then stubs, yeah, those things provide canned answers to calls made during the test. So think wire mock. So if you have a RESTful service, you send out a request, it gets the request, goes, ooh, I know this request, I'm going to send this canned response. That's a stub. Spy is very similar, but with a spy, you can actually interrogate it to find out what kind of calls were made to it, which can be handy, okay? They're really handy for doing component tests, etc. I'll show you now in a sec. And then the mocks, as we know, JUnit mocks to mock all those external dependencies so you can concentrate on just the unit and the behavior of the unit and the design of the unit, all right? So if we plug them into our diagram here, this is what it looks like. In actual fact, diagram's a bit wrong. The stub spies and fakes, they can be interchanged between integration and component, but you can see the mocks there for your unit. The fakes for the integration, test containers, things like that. Integration also might talk to a RESTful service, right, or do contract tests, so they might use some stubs and spies. And then the component test itself. When you boot up that component and you need to talk to test doubles, you can use a mixture of stub spies and the integration. With the fakes as well, in order to get to control the environment. And we go on about to control the environment here, right? This came straight out of the book, Continuous Delivery. Blew my mind when we were out going and researching this stuff, right? So acceptance testing should be focused on providing a controllable environment in which the system under test can be run. I keep banging on about this stuff, but it's crucial. If you start up your applications talking to the real thing, you got a problem because you can't create the conditions that you want to exercise the behavior in your application. If you have a condition where one of your external dependencies, it gets in an error state, or there's a retry or something like that, and your behavior of your application changes accordingly, you can't exercise it by talking to the real thing, unless for some reason the provider of the real thing is giving you this tests. It's just a test instance that you can control, and you can say, hey, enter these kinds of conditions so that I can test out my behavior, which is unlikely. So it's on you to build these things. Test double gets you out of that situation, right? Now, one thing that does come up though is that, say with integration testing, when it comes to talking to a RESTful service, for example, with a contract, right? How do you know that you have a truly faithful representation of that test double? So this is Martin Fowler again, and he's saying an obvious catch with integration testing against double is whether that double is truly faithful. But we can test that separately using contract tests, right? So how do you make sure that the canned response is faithful, right? Contract This is consumer-driven contract testing, right? It's hard to read and all that kind of stuff, but I'll explain it basically. You have a relationship between the provider and the consumer, right? The consumer says, based on the documentation I've read, I see all the things, right? I will give you this request. I expect this response. You hand it to the provider. The provider looks at that and says, okay, based on this request, I can satisfy that. I will give you this response. They take that in. That becomes a test, an integration test against their stuff. If they change their stuff and break the test, they know before they've impacted you. And they have a hard call. They can go, right, do I need to pick up the phone to my consumer and say, hey, break and change, we need to have a discussion, or have I broken something, do I need to fix it? At the same time, the same contract goes into, say, Artifactory or something like that, becomes available for the consumer to pull down, right, because it's been agreed upon, right? That's the path. So the consumer goes, right, I'm going to pull this contract down, and I'm going to use it to provide a test double. So the test double comes up, Wiremock or something like that. Your integration test sends the request. Ooh, I know this request. I'm going to give it the canned response. Canned response comes in, and now your consumer-driven contract test, or part of the integration test suite, can behave. It'll be exercised its behavior accordingly. If you mess up your code, it will break, and you will find out why. It's because the contract is broken, right? Or maybe you're not adhering to the contract, right? Cool. So, using narrow integration tests and contract tests, I can be confident of integrating against an external service without ever running tests against a real instance of that service. And now you've got speed, because I can work in parallel. We've agreed on a contract. I can work in parallel. I can work at different speeds, right? We got different speed IT. I don't have to wait for your service to be perfect before mine goes out. I can put mine out there behind a feature flag, right? And then when yours goes live, I can switch it on. Low risk, because if it breaks, I switch it off again. Right? And with good governance and process, you can keep an eye on these things so that they don't go and explode when feature flags, etc. And you can keep this cadence, and you get further towards that whole continuous delivery, utopia that we're looking for, right? Or given the context. So that's it really. To wrap up then for our teams, what we're doing for our teams is we're providing measures. We need metrics to help them figure out, to baseline where they are, to know when they start making tweaks and they start pulling in these practices and applying them, are they making progress, right? In terms of like cycle time, in terms of production bugs, in terms of number of, percentage of tests written by developers. As crazy as it sounds, there's still a bunch of like separate test teams out there writing tests for developers. And if we think back to our Agile manifesto or the testing manifesto, it says you test your understanding. So as a developer, how are you testing your understanding of how your application should work when you're handing the tests off to somebody else, right? And then testers are absolutely brilliant. They have a total place in this world, right? How are you working with testers to come up with the different scenarios and to work on, the different ways that you can exercise and improve your testing practices over time? Ever heard of the three amigos where you're hanging out with product, developer, and tester coming together? All that knowledge about how the thing works, and then building your understanding of how your application is supposed to work into tests before you've even written code. This is it, all right? We're doing that with pilot teams. We've got pilot teams that we're working with. We're having conversations with them. What does testing mean to you? What's your context? What kind of practices work with you as we go forward? Okay, and then we're providing them with code samples. It's not good enough to just show them some sort of practice library and say, hey, go read that. No, wait. The practice library is to refer back to when you're having conversations with them. The code samples are there to help you make it real for them. They could just pull it down and start accelerating ahead. And then we got a diagnosis guide, right? Sounds a bit weird, but basically if you're seeing, production problems or whatever it is, quality problems, the diagnosis guide helps point you to practices that will help you. So it's self-serve. And then a testing strategy template. If you have the conversation together, what does testing mean to us? What are we going to do about it? How are we going to implement quality as a team or a team of teams? Write it down. Write it down so you can refer back to it. Write it down and build it into your workflow so that when you say swim lane, test, here's the link to the testing strategy, this is what we do. When I move that over, I say it's done according to the testing strategy that we all agreed and committed to. All right? And then last one is testing assessment model. Right, which is basically if you're not seeing problems in production, say you have great coverage, right, but you have an over-reliance on end-to-end testing, for example, right? What What's your awareness of what other techniques are out there to get faster, right? It's kind of like a maturity model. I don't like maturity though, right? Because given your context, you might not need or different practices. I like an awareness model. So you can see what's out there and what you can leverage going forward. So that is the journey that we are on. And that's how we're implementing testing excellence, right? As part of our initiative to raise all boats and to standardize our testing practices in Liberty IT. That's it. Thank you. Questions,
Yes.
if you have them. Yes, questions.
I was going to say, any questions? There we go. I'm going to get my steps up here.
Hi, thanks very much. Very interesting talk. You'd mentioned that the testing is a part of a high-performance library that you're using.
Yep.
Obviously, sort of what you write can be more testable or less prone to the errors that you're finding in testing. What sort of things have you seen feedback into how you actually sort of like make things available in the library, how you implement things, framework choices and stuff like that that have arisen from testing to make the software more testable and less prone to error?
Make the software more testable. I'll come down to you, lad, because I can't hear you. What's up? Sorry.
So you mentioned that the testing portion was an element of a high-performance library.
Yes, yeah.
Testing sometimes can be treated as like something that gets done after the fact.
Oh, yeah, yeah.
But how you implement and your choices at the implementation level can make things fundamentally more difficult to test, more difficult to actually achieve the goals you want. What sort of things have you found through this feedback loop that have fed into how you actually build software in the first place?
So when we go with the pilot teams, we go and we have chats with them and try to build context, right? Because you can't just go in and get the pyramid and go, right, go. Right? So we'll have to have the conversation to see where they're feeling pain points, where they're getting slow. And you have to start with measurements, right? So measurements are hard, right? And folks are thinking, so we start with like, what are you seeing in production, right? And what kind of things are you seeing in production, right? And then we talk about, what kind of testing practices and things like that you can apply, right? But we have to measure it first, right? And then we help the teams, come up with the testing practice. Now, what kinds of things are we seeing out there? There is a lot of unit tests and there's a lot of end-to-end tests and there's nothing in between, right? So how you develop software, I love to think of testing as upfront design technique, okay? So with your unit tests, if you're using test-driven development, for example, you're thinking about the design of your code before you've written your code. Same with integration tests, right? So if you think about how my thing is going to interact with an external dependency, if you look at component tests or behavior-driven tests, right, you're thinking about the behavior of these things. So what we're finding is that, you're trying to catch this stuff later on in your end-to-end, right? And it's kind of like you're finding things later, big, feedback loops, etc. How are you designing? How are you thinking about design? How are you thinking about SLAs, for your application, the behavior, who you're talking to, the product owner, the tester, etc., in order to build in the quality earlier, according to your understanding. So it's changing the way that we think about software development in that sense. Rather than it being reactive, it's now becoming, you build it in from the start. Does that help?
Yeah, and you're treating it as like a single thing. It's not that it's just testing in isolation. You are looking at that piece around design and stuff.
Around design, yeah. So the practice library, the HPE stuff that we have, 12 focus areas, right? So it's across testing, it's across tech debt, it's across security, it's across, product, it's across multiple things. And we're trying to take that, there are many lenses to apply when you're looking at software development. Right, it can be a little bit overwhelming. That's why we like to, narrow it down to focus, to build up certain skills as you see them within the context of the team, because every team is going to be different. So, yeah.
Okay, wonderful. Thank you so much. Apologies, folks, though, we don't have any time left for questions. However, I'm pretty sure Karl will be hanging around for the rest of today, so you can grab him for a coffee chat. If you join us in the next 5-10 minutes, we're going to have Jason Bell talking all things AI and data. So we'll see you all in 10 minutes. Thank you.